In this video, we're going to derive the half-angle formulas for sine and cosine. And again, they're both going to come from the double angle formula for cosine. That's because the double angle formula for cosine gives us three versions. The version that falls directly out of the sum formula gives me a relationship between three different trig functions. But if I use my Pythagorean identity, I can get that down to a relationship between two trig functions. Cosine of 2 theta is always one of them. In this version, the other one is sine squared theta. And in this one, the other one is cosine squared theta. Let's actually start with that third one. Cosine of 2 theta is 2 cosine squared theta minus 1. Okay. Now, the way I've named my angles here, theta and 2 theta are the two angles, that naming really emphasizes the fact that this one is twice as big as that one. But another way of saying that is that this one is half as big as that one. And that's really all we're going to do with the half angle formula, is we're going to rename things to emphasize that fact. So I'm going to let alpha be 2 theta, and that's going to mean that theta will be alpha over 2. Okay. Naming things this way just emphasizes the fact that the smaller one is half the bigger one. So if I rewrite this in terms of alpha, this becomes cosine of alpha is 2 cosine squared alpha over 2 minus 1. Now, I'm going to solve that for cosine squared of alpha over 2. So I'm going to add over the 1, divide by 2. So we'll have cosine squared of alpha over 2 is cosine alpha plus 1 all over 2. Excellent. Now, if I want to take things one step further, I could take the square root of both sides. So, I will have the square root of cosine alpha plus 1 over 2 is the square root of cosine squared alpha over 2. And I do need to be careful here, because while I can simplify this right-hand side, it does not simplify to cosine of alpha over 2. Because cosine is sometimes negative, but this thing that I'm saying the right side is equal to is never negative, because it's a principal square root. So remember, when you take the square root of something squared, you get the absolute value of that thing. Okay. So we have the absolute value of cosine of alpha over 2 is equal to the square root of cosine alpha plus 1 over 2. And of course, that's going to mean that cosine of alpha over 2 will either be plus or minus the square root of cosine alpha plus 1 over 2. If it's positive, it will just be this square root. If it's negative, it will be the opposite of that. Now, this is the version that's given in your textbook. And I'm not crazy about that, because it suggests that there are two options. But there aren't. Only one of those is right. So it's important that we recognize that it's not just, it's both plus and minus. It can't be two different things, because cosine is a well-defined function. And it's not that you get to just flip a coin and decide which one you're going to make it. The plus or minus sign is always going to be determined by the quadrant that we're in. Okay. Here, we're talking about taking cosine of alpha over 2. So whatever quadrant alpha over 2 ends up in, that's going to determine the sign. So the plus or minus sign is determined by the quadrant, not of alpha, but of alpha over 2. Because that's the thing whose cosine we're calculating with this half angle formula. Okay. So super important to remember that the plus or minus sign is uniquely determined. We just have to pay attention to what quadrant our half angle is actually in. Okay. All right. So there is our half angle formula for cosine. Let's do the same thing for sine. So there, the version of the double angle formula that I'll start with is that cosine of 2 theta is 1 minus 2 sine squared of theta. I'll do the same substitution. I'm going to call 2 theta alpha. So this becomes cosine alpha, and then theta becomes alpha over 2. So 1 minus 2 sine squared alpha over 2. I'm going to solve for sine squared. And to make it positive, I'm going to add it over to the left side, and then I'll subtract over the cosine alpha. So we'll have 2 sine squared alpha over 2 is 1 minus cosine alpha. And then I can divide both sides by this 2. So sine squared alpha over 2 is 1 minus cosine of alpha all over 2. And again, I can take the square root of both sides. Once again, the square root of sine squared is going to be the absolute value of sine of alpha over 2. And that's going to mean that sine of alpha over 2 will be plus or minus this lovely square root, 1 minus cosine of alpha all over 2. Okay. Again, that plus or minus sign, you don't get to just pick one. That's going to be determined by the quadrant that we're in. And since this is a formula for determining the sine of alpha over 2 is the angle whose quadrant we care about. Okay, fabulous. Now, these formulas are going to sometimes lead to some somewhat messy expressions because it's already a square root, and we've seen that sometimes roots do show up as in the cosines of various angles. So we could have roots of roots, and we're going to be okay with that. I am going to insist, though, that we simplify things as far as we can, as far as getting rid of any complex fractions or anything under the radical. So let's just try an example. I'll keep these formulas up. And let's say I know that sine of alpha is negative 2/3, okay, and pi is less than alpha is less than 3 pi over 2. So I'm essentially telling you that alpha is in quadrant 3, okay. And let's say I wanted to evaluate, let's go for cosine of alpha over 2. Okay. All right, so I know from my formula here that it's going to be plus or minus the square root of cosine of alpha plus 1 over 2. Let's deal with that plus or minus right off the bat. Okay. Now I need to be careful. This is telling me that alpha's in quadrant 3, but I'm not taking cosine of alpha. I'm taking cosine of alpha over 2. So what I'm going to do is take this inequality and I'm going to divide through by 2. Now over here where I already had a fraction, I'm just going to use the fact that dividing by 2 is multiplying by 1/2. So that's going to tell me that pi over 2 is less than alpha over 2 is less than 3 pi over 4. Okay. Well, what that does is that puts me in quadrant 2. This would be pi over 2. This would be 3 pi over 4. So I know not only am I in quadrant 2, I'm actually in the first half of it that I would hit if I were rotating through it. So, because we're in quadrant 2, I'm going to say that cosine is negative. And I'm going to justify that by saying that we are in quadrant 2. In fact, I'll even say alpha over 2 is in quadrant 2. To receive credit for this, I need to see that you have solved for what quadrant alpha over 2 is in. Okay, so you don't have a 50-50 chance of just getting the right sign. You need to justify it. You need to justify it by figuring out where the angle that we're taking cosine of actually is. Okay, fabulous. So we've determined what that sign is going to be. Now I need to know what cosine of alpha is. Now for that, I'm going to be concerned about alpha. So I am going to need to know that alpha itself is in quadrant 3. Okay. So let's see. I know that sine of alpha is negative 2/3 and alpha's in quadrant 3. I'm not crazy about this choice. I used alpha because that's what the book does, and I wanted to give the formula in the same way. I usually reserve alpha to be my reference angle, and obviously it can't be here. That's okay. I'm going to let my reference angle be beta. We'll just go up one letter in the Greek alphabet. Okay, and so we're trying to evaluate cosine of alpha. That's going to be our usual two-step process. Now, alpha is in quadrant 3, where cosine is negative. So this negative sign is because we're in quadrant 3. This one was because this angle is in quadrant 2. Okay, and then what I know about alpha is that, beta, is that sine of beta, my reference angle, is the absolute value of negative 2/3, which would just be 2/3. So I'll label the opposite side 2, the hypotenuse 3, and I'd like to solve for the adjacent side. Okay. So a squared plus 2 squared is equal to 3 squared. A squared plus 4 is 9. A squared is 5. And a would be the positive square root of 5 because it's a side length. Okay. So the absolute value that I'm going to attach to that negative sign is cosine of the reference angle beta. That's going to be root 5 over 3. Okay, so now I can come over here and plug that in. So we're going to have negative square root of negative root 5 over 3 plus 1 all over 2. Okay, now that's a complex fraction under here. I don't want to go with a complex fraction, so to clear the complex fraction, I'm going to multiply by 1 in the form of 3/3 because 3 is the thing that I want to cancel. Okay, and I'm doing that under that radical. Okay, all right, so this is negative root. This will now become just negative root 5 plus 3 all over 6. Okay. That's as far as you need to get. I'm okay with there being a root under a root, but everything else that we've been doing, that root is as simple as it can be, and I don't have any complex fractions. Okay. All right, excellent. So that's how we can use that half angle formula.